In the last video, we used geometry rules to determine the area of each one of these sections. Again, area of a triangle, area of a half circle, area of another triangle, and area of a finally fourth triangle. Now, we need to make sure we're very careful about evaluating these integrals based on those areas, because the integral calculates something very, very specific. Again, the integral is nothing more than the limit definition of the summation of an infinite number of added up rectangles. So, if I'm going to go from x equals 2 to 4, that means I'm looking at the area starting here, cutting this space up into an infinite number of rectangles that approximates the area up till 4. But again, if we use an infinite number of rectangles, it no longer approximates that. Not to mention also the fact that this is simply a triangle, and the area of this triangle is nothing more than, in the previous video, 2. So the integral from 2 to 4 is the value of 2. Next, let's look at the integral from negative 2 to 2 of f of x dx. Now that's this space here. So I'm going to start here. I'm going to find the area under the curve of this entire thing by cutting it up into an infinite number of rectangles. That infinite number of rectangles will add up and provide me with an area of 2 pi. There is a slight issue with this, however. One thing we need to make sure we note, and I did write it in here, is that the integral calculates the area below the x-axis as a negative value. So I want you to think of it this way. In this example over here, we are slicing this thing vertically, starting from the function, cutting back to the x-axis, and all of those areas are considered as positive. However, when we're cutting this one, we're again starting with the function, cutting back to the x-axis. So that kind of behaves as though we're cutting it in a negative direction, which means that all of these little rectangles are going to have a negative area. So one thing to make sure we note is, number one, from negative 2 to 2, the area under the curve, well, there's no curve up here. The curve down here forces us to calculate this as a negative area. So the area of that space is 2 pi, but because the integral calculates negative area if the area is under the x-axis, that's going to be a negative 2 pi. For number 3, we're calculating it from 6 to 4. So now we're looking at this space right here, but this time we're starting here and we're cutting it backwards. Another thing about the integral that's very unique is that it cuts an integral backwards, forces us to calculate that area negatively. So again, two details that we need to make sure we remember. This right here will be an obvious positive area from 2 to 4. This from here to here, going from 4 to 6, would be a positive area as well. However, if I reverse the order, going from 6 to 4, it will change that area calculated to be negative. And that's, again, under the curve also calculates area to be negative if it's below the x-axis. So the area from 4 to 6, if I calculate it going from 4 here to 6 here, is a value of 2. But because I'm integrating from 6 to 4, I'm cutting that object backwards, I now have a negative 2 area.